So this idea of solving inequations, so left-hand side is greater than right-hand side, and we have to solve that sort of problem. This technique is very efficient and is a very common way of doing it. Instead of solving left-hand side greater than right-hand side, we just move everything to one side, in this case left-hand side minus right-hand side, and show it's greater than 0. Why do it? Because trying to find where something's positive or negative is a lot easier than, say, trying to find out when is it bigger than 1, when is it bigger than 5. Now, a lot easier to say when is it bigger than 0. In other words, when is it positive or when is it negative. Much easier idea. Because then we just look for the critical points of the domain. Because a function, you can only change from positive to negative. You think of the graph, you were to draw it. When does it go from below the axis to above the axis? There's only 2 times it can happen. At an x-intercept, it's got to pass through 0. So we find those x-intercepts. The other time, of course, is if there's a discontinuity. There's the hyperbola over there. That's a perfect example of it. It goes from negative to positive, but look at x equals 0. There's a break there. There's an asymptote. But they're the only 2 situations. So if we can find those things, that gives us our critical points. Just a reminder of bracket interval notation. The square bracket, that means the interval's endpoint is included. The parenthesis, that means it's not included. So closed brackets on both sides, then we call it closed. So all the endpoints are included. Whereas if it was parentheses on both sides, we call that open. And so the endpoints are not included. We say it's unbounded if part of that interval just keeps going to infinity. There is no boundary, it just keeps going. How do we draw them? X is greater than 5, I'm incredibly fussy. This is how I do it. You circle the point in this case because it's not equal to as well. I always put my arrow above the number line because I find that if you put it on the number line, you can lose it. Certainly if you're using a similar colour ink or something like that. So if you put it slightly above, don't exaggerate it and put it miles above, slightly above, then it's clear where it's going. So that one there is an open because the endpoint's not included. It's unbounded because it's going off to infinity interval. That's how we would put it in the bracket notation. 5, but it's going off to infinity. And another way, if it was a domain we were writing down, we could write it like this. X, the colon basically means such that. So x such that these x's are greater than 5. Less than or equal to 6, the only difference is we colour it in to indicate it is included. So that's a closed unbounded interval. That's how we'd write that one. In between 2 points, that one is, again, it's open, endpoint's not included, but this one's bounded. We've got boundaries on this one. And that would be a closed bounded one, the endpoint's included. What happens if one's included and one's not included? Is it open or is it closed? Well, we just call it bounded. You know, one side's open, one side's closed. So we can't really classify it as either. So we just call it a bounded interval. And then something like this. Oh my goodness, what's going on there? Well, we just say, look, that's just a union of 2 other intervals. Talk a little bit about composite functions. We saw that back in, was that term 1? Might have been term 1, composite functions. So that's when you get 2 or more functions to create a new one. So something like that, where you substitute this function we call gx into the function we're calling fx. A notation for that is the open circle there. It's not the letter O. Mind you, a lot of people just read it as fog. But it's gx going into the function f. Here's my 2 functions. So if I wanted to find fog, I would substitute the 1 on x squared into function x. Let's play around with this, make it look a lot neater. Want to get rid of the bottom of the fraction, multiply everything by x squared, and we have our new function. If I went the other way, goff, now we're substituting function x into g of x, and play around with that one. So let's go and talk about inequalities. Here it is, this is what we have to solve. Already we're just talking about everything's less than or equal to 0, so we don't have to do anything. Critical points, x-intercepts or discontinuities. Well, there's no discontinuities on this one, but there's certainly going to be x-intercepts who are going to draw it. So we know the critical points are going to be 1 and -3. They are included. So we have a bounded interval here because of the equal to sign in the inequality. The question now is, which section are we in? And it's just a matter of picking numbers and finding out. Or of course you could draw the complete graph and see when is it below the axis. Your call how you want to do it. Let's see, if we sub in 0, what do we get? -1 squared is positive. Well, we get positive. So 0 is not going to be part of my solution. Sub in -2, the first one is positive because we're squaring it. The second one's positive. Oh, so actually, no, we are not in between 1 and -3. On the very left of -3, though, let's pick -10. -11 squared, that's going to be positive. -10 plus 3, that's negative. That is included. We're going to end up with that solution. It's interesting in that we have a single point at 1, a single point which is included. So there's my solution. X is less than or equal to -3, or X equals 1. Here they are, pronumeral in the denominator. Lots of different ways of solving it. I'm going to use this left-hand side minus right-hand side idea. If I was to move everything to the left-hand side, let's just tidy it up. There we go. Now, when it's in this form, it's great, because the x-intercept must be the top of the fraction. So what makes the top of the fraction equal to 0? And the discontinuity must be the bottom of the fraction, because you can't have 0 in the bottom of the fraction. That's how we find our two critical points. So it's -13 on 5 and -3. In this case, it's open, because we do not have an equal to sign. So I leave it as open. Testing the regions again, and we would find out that we turn out to be on the outside of those 2 points. I just think that's so much quicker than squaring the denominator, multiplying out and all that. Just so much quicker. There's my final solution. Okay, that shall do us for today.